Okay, here we go on our mixtures PowerPoint. So the big idea of the overall unit that we're going to be doing is that everyday materials are often homogeneous solutions, heterogeneous mixtures. You should be able to have an understanding of this big idea and what all those terms mean by the end of this unit. Questions you should be able to answer by the end of the unit. Number 1, what is a heterogeneous mixture? And number 2, how does a heterogeneous mixture compare to a homogeneous mixture, which can also be called a solution? So the vocabulary for this unit, our first one, is matter. Matter is anything that takes up space, has mass, and is made up of particles. Basically, this means anything you can touch, see, feel. Your desk is made up of matter. You are made up of matter. The air around you is made up of matter. Pure substances is a material that is composed of only one type of particle. Examples of this would be something like gold or oxygen. Anything on the periodic table. For our purposes, water, even though it's made up of hydrogen and oxygen, is considered a pure substance as well. Right here is the periodic table. If we're thinking about water, we're taking oxygen and hydrogen. We're joining them together, which makes H2O. H2O, representing water, would be considered a pure substance. So a mixture. A mixture is something or a material that's made up of at least two different pure substances. Not limited to, but at least two things combined together. The first kind of mixture we're going to look at is something called a mechanical mixture. So a mechanical mixture is a mixture in which each material in the mixture maintains its own properties. So if we take a look at this, we have here, we've got some M&Ms, we've got some almonds, we have other types of nuts here, we have some raisins in here. Oh, come on. All of those things are representing, all together are the mechanical mixture. But by themselves, this is still an M&M. These are still nuts. These over here are still raisins that you could pick out if you wanted to, and just eat them separately. A solution is a mixture in which the distinct properties of the different substances are combined into one set of properties. So think about salt water. If I just have a regular thing of water and I have a thing of salt, each of these things are substances in themselves. We would consider them pure substances if we had pure water and pure salt. They have a unique set of properties and they're all one thing. If I take the salt, though, and I add it into the water, at the start we're going to see the salt kind of sitting there. But ultimately, the substance is going to look something like this, which, just by looking at it, is indistinguishable from what we started with, even though if we drank that, we know that it would be considerably more salty and would taste kind of disgusting. This is an example of a solution where we can't visually see the difference, but it's changed. And we'll get into what the different parts of what the solution is later on. Another term for solution would be a homogeneous mixture. A homogeneous mixture means that it's all the same. So the materials have one set of properties. Key thing is that you cannot see the parts that make up the mixture. So an example we have here is, as we already talked about, salt water. If you think about steel, steel is made up of iron and a combination with carbon. Bronze is made up of copper and tin. And pop is a mixture of a whole bunch of substances, but primarily is water, sugar, or a syrupy kind of mixture, as well as carbon dioxide. So all these things are in themselves their own thing, but are made up of different components that combine to make those things. The heterogeneous mixture. This is just like the mechanical mixture that we saw a little earlier. So a heterogeneous mixture is a mixture that's made up of parts that retain their own properties. So it's made up of different things that remain as different things. So think of the trail mix that we saw right at the start. Pizza is an example of it, where you have the dough, you have your toppings and cheese that are things that if you really wanted to, you could pick each part out. If you think about Bay's fishbowl, and I'll draw it here. Bay's fishbowl has water in it. It's got rocks at the bottom. It has bay in it. There we go. We have at least 3 different parts here. We have the rocks at the bottom. We have the water. We have Bay himself, who's part of that environment. All those things combine to make what's in that fishbowl. So now we're going to start looking at the different parts that make up a solution. This is specifically for a solution or a homogeneous mixture, as it relates to the part that dissolves things and is dissolved. So the first thing that we have is a solute. Solute is the substance that is dissolved in something. So if we go back to our salt and our water example, the salt is the solute. So, I want to zoom in. What this means is it dissolves. I spelled dissolve wrong. It dissolves in water. So remember, if we go back to that, we dump the salt into the water, and we get all our little things in there. We can at the very start, we can actually see the salt, and then our water just turns normal. So the solvent is the thing that the solute dissolves. So our big one is going to be water. Water is the solvent that dissolves sugar, which is the solute. Salt would also be the solute. Alright, so now we're going to look at how we can separate some different solutions. Filtration is one of the easiest ways that we can do it, though it doesn't work with everything. For all this filtration, I'm going to use the example of making coffee. So for coffee, what we do is we set up a filter, we throw the beans into that, and then we push water through that. And what comes out is coffee. And we have 2 separate parts for this. The first part is the filtrate. The filtrate is the actual coffee in your cup. So the filtrate is the part that actually comes through the filter and passes through. To depending on what you want. You might collect it or you might just let it run off. The filtrate is the part that's left over. So if we look at this, we have the filter here. And inside we have all of the coffee grounds. For the purposes of coffee, we wanted the filtrate and did not want the coffee grounds. So we usually throw the coffee grounds out. The coffee grounds would be considered the residue, or the part that's left over from the filtration process. Distillation is similar to filtration. Again, its purpose is to split up or get rid of something that's in a liquid. What we do is we start usually with our solution. So here we have our salt water in here, and what happens is we heat it up. Now if you think about it, when you boil water, water evaporates. Salt doesn't. So this water will evaporate up here, and then it goes down through this apparatus, and as it goes it cools down. And as it cools down, it turns back into water droplets, and it drips into whatever you're trying to catch it with. The salt will stay in here. This process gives us either fresh water, or we'll be left over with salt in here, depending on what we want. We potentially might want both the salt and the fresh water, depending on what our purpose is. In this process, we can think of the pure water as the filtrate, and the salt that's left over as the residue. Right, now we have dissolve. To dissolve something is the act of a solute completely combining with a solvent to become a solution. Basically, this means that you have one thing, think of the salt, combining with the water, and they become one thing. If something is soluble, that means that a solute is able to dissolve in a solvent. So, for instance, sugar, if it is put in water, will dissolve. That means that sugar is soluble in water. If something is insoluble, it means that it is not able to dissolve in another substance. For this, you need to be specific about the substance. So, for instance, you would say that oil is insoluble with water. It might be soluble with other things. For instance, if you had soap, the soap binds and changes things. But oil by itself is insoluble with water. When you're making solutions, we can have different kinds, and we can do different things with it. So the first thing we can do is dilute it. What diluting a solution means is that you're going to weaken the strength of it. To think this through, think of having a glass of juice or a glass of iced tea, and you add more water to it. That's going to make it taste weaker and more like water. When we do this, it's called a dilute solution, or a solution that contains a small amount of solute. The opposite of this is to strengthen it. And to strengthen a solution means you add more solute to it. So if you think back to our glass of juice, it means we would add more juice powder or iced tea powder into it to make it taste stronger. When we do this, it's called a concentrated solution. When we use the term saturated, what this means is that a solution in which no more solute can be dissolved at a given temperature. So if something is saturated, nothing else of that same solute will dissolve into the solvent. It means that the solvent is holding as much as possible. Our final one is supersaturated. So supersaturated solution is where we have a solution that is already saturated and we heat it up. And by heating it up, it allows the solvent to hold more solute. You can think of this in terms of hot chocolate, that when we heat it up, the powder mixes better into it, and we're able to get a stronger cup of hot chocolate. And that is mixtures.